Hey everyone, welcome to day 14. Today is the 16th of March and we are continuing on with storage. And the first thing we'll talk about is DAS, NAS, and SAN. So these are three commonly used external storage technologies. DAS stands for Direct Attached Storage, Network Attached Storage is NAS, and Storage Area Network for SAN. So obviously, while like onboard storage or like attached external drive is fine for like everyday common use for your laptop, when you're working at a big company or just a company in general with a lot of different people, a lot of laptops, it's with high demand web applications, it's not enough, right? So there needs to be other ways for storage to work. And so first one we're talking about out of the three is direct attached storage. You can tell from the name what it is, right? It connects storage directly to the host system, and it's all good for small businesses environments where storage is not really shared among multiple servers. But since it's directly attached, that means that it's limited in scalability, so it's not as ideal for larger environments that demand shared and flexible storage solutions. Next, we have network attached storage, and like the name suggests, it's pretty much just shared file storage accessible over a network, as it's not directly physically connected to the host, as data is transferred through a network connection. But it's good for mid to large businesses, and NAS typically functions as an NFS server. We'll talk about what NFS is in a minute. Exporting storage as directories or shares that can be accessed simultaneously by multiple hosts. It's designed to support centralized shared storage with high availability and good performance. And so it's very well suited for web servers, application servers, and non-production database environments. Next, we have storage area network. That's for like the super big enterprises, because in this system, storage is allocated to hosts as logical unit numbers or LUNs, which represents sections of a shared storage pool presented as logical disks to the server. So when a host system detects a storage area network device, it will appear as raw disk where like the partitions and file systems can be created. So just like any other block device. And it's best for handling mission critical applications in databases such as Oracle, Microsoft SQL Server, and virtualized environments like using platforms like VMware, KVM, or Microsoft Hyper 5 due to its high performance and reliability. And we mentioned this earlier, NFS. So now we're here to NFS, which we mentioned earlier, which stands for Network File System. I don't know if this is the proper way to say Network File System, but it's just there for now. You can correct me if I'm wrong, but I think people do say this. And so this is different from block devices, as when block devices is stored in like blocks, right, in chunks, but NFS, it stores data as individual files, and it utilizes a servant-client model to share directories across the network. For instance, imagine a software repository server which maintains the directory at /software/repos. And by extorting this directory using NFS, the employees' laptops can access its contents as if the files were just stored locally in the computer, despite them being on the server. So this is very useful. So some key command is the export FSA to export all the mounts defined in export files. And you can also use, if you want to do a specific client, you can run export FS with the O flag and then the IP address and location. And then once it's exported on the server, you can mount it on the client machine. And to do that, mount IP address of the machine, and then location, and then mount software repo. And next we move on to LVM, which stands for Logical Volume Manager. It's very powerful as it lets you group multiple physical volumes, such as which are disks or partitions, into a single volume group, VG. And then in this group, you can even allocate one or more logical volumes, right? So the examples that we will be using, we use 3 partitions, but just keep in mind that LVM is something that can do much more than just 3. And also another thing is that they can dynamically resize logical volumes, which means they can change how much storage each partition has. So it's very flexible. And so how do we do that? What are some codes? First of all, make sure that LVM2 is installed. So let's check that. apt get install LVM2. Oh, that's right. Must be on the root. I did that wrong. That's alright. Try again. There you go. So the first step is to create a physical volume, PV. That's how it's shortened it. And when this represents the disk or partition within the LVM. So example, if you want to create physical volume on path/dev/sdb, so you should simply write pv create and then the directory. And to create a volume group, vg create. So these are both pretty simple, and then the name you want it, and then the directory. And to display the details, simply run pv display. Right, and then here you can see the name of the PV, the VG name, size, and next we have VG display. Right, it gives us more information about that. Then what can do, like access, and the size, and then step 3, we have to create a logical volume. Not have to, but to create a logical volume is this is after you make a volume group, you can create logical volumes within it. So let's try it. Let's try LV create. So let's see how much I have. 17 gigabytes, so it should be good. So LV create, and then the option L is for the size. Let's go 1 gigabyte. What should we call it? Let's follow it, and then Ubuntu VG. There you go. Now if we do VG display. There you go. So sorry, it was LV display. You can see we made one with volume 1. The size is 1 gigabyte, right? Because that's what we wrote. Right, and in step 4, create a mountain file system. So once everything's in place, we can create an extended full file system on /dev/. This is just an example, so I don't actually have this one yet. But simply, the command is mkfs.ext4, and then where you want it. And after it's created, you can mount it to a directory, such as another typo, /mnt/volume1 to make it accessible. So mount option T ext4, and then the location of where it is and where you want to mount it. And then another thing is you can resize it, right? Sorry, I keep forgetting. So you can always, let's say for volume 1, I want to give it some more, right? That's the only one I have. So let's go sudo lv resize, and then option capital L for the how much you want. So let's go +1 GB as well. And then it's under /div/ubuntu dg/volume1. And this, once we run it, all good. So now let's go sudo lv display, and it should be 2 gigabytes in the lv size now. Yep, so we gave it, so it's very easy to resize, which is really nice. And next I want to work on the project with you guys. So here's the exercise. This is day 2, right? Create a directory called project in your home directory. So let's do that. CD to go back home. We can check it with pwd. Where home? Yeah. Okay, so create a directory called project. So mkdir project. And inside project, so let's go to project. Create 3 subdirectories, doc. So ignore that. So mkdir doc. And src source. Yeah, and test. So let's check if they're all there. Yep, all there. And in each subdirectory, create an empty file called readme.md. Okay. So let's do that. So to make it, we do touch. Let's go doc first /readme. How's it spelled? Oh, full caps. readme.md. And next we touch source /readme.md. And then finally touch test /readme.md. Now let's just check if it's all good. Yep, that's in there. It should be all in there. I'm gonna trust myself. And then we're starting from home directory, navigate to the source using single command. Okay, that's cd source. List the contents of the source. Okay. Move back to project. So cd dot. Let's go backwards. So back in projects. List all subdirectories of project in long format. So that's just the option L, I believe. And next we got file manipulation. Create a file named total.txt in the product directory. Okay, so we're already in here. So line complete dash script calls tutorial using the echo command output redirection. So it gave us a hint using Gcode, right? So oops. So what do we do? Complete. Okay. Echo complete bash course. Bash scripting. And then we want to append it to total. So that should do it. Make a copy of total.txt in the docs directory. So copy total.txt. Okay, so we want to put it into the docs. Oh, I think I made a mistake. Yeah, I wanted me to do docs, not doc. So I need to rename it. That's fine. So let's do that first. How do I rename it? I believe I can just move it, right? So move doc. Docs. Now. Yep. It's done. So now let's continue. So copy. Copy todo.txt into docs. Now let's check if it's in there. Yep, it's in there. What's next? Rename the copy. Okay, so cd. Let's go to docs. And then let's move todo.txt to tasks.txt. Done. Search and display. Use the find command to locate all readme files in the project directory and the subdirectories. Okay, so let's go cd find read. See if that works. Nope. Oh, I forgot the option. Sorry. Yep, there you go. That's better. Use the grep to search for the word complete in all text files. So that would be grep. Oh no, it'll be grep r complete. Yeah, that's right. Clean up, remove the tests directory and all its contents. Okay. rm tests. Oh, it's of course. That should be gone. So it's a directory, so we need to add the option. R. Move tasks from docs source. Bonus challenge. Write a bash script that automates the creation of the directory. Okay, let's just do the first one for now. Easy, right? mv docs txt to source. Okay, I need some time to think about this one. We have to go through my notes. But yeah, I'll get back to you guys when I think of something. I guess let's just set up the directory first. So let's go day 2. Day 2 bonus equals. Let's try again. Okay, that one worked. Yes, we make the directories now. So doc source and tests. mkdir day 2 bonus docs source tests. Sorry, I wasn't in the right. Okay, that's my bad. Something. I think I know. Option P. I think that worked. Okay, so touch. Day 2 bonus. Read me not empty. And then day 2 bonus. Oh no. Box. And then day 2 bonus. Source slash readme empty. And then day 2 bonus slash tests slash readme empty. I think that's it. Okay, I believe that's everything we need to do. So let's open that up in File Editor. Okay, let's type everything out. Then press I to enter insert mode. I believe it's bash. So let's just type everything again. Make a directory, right? Yeah, make it easier for myself. Go. Let's save. Oh wait, no, I pasted the wrong one. Alright, that's fine. I know how to. Okay, I believe that's that. Let's say let's delete this. And let's run. There you go. Don't know why there's a slash in front of it. Oh, I just wrote it. Oops. Okay, yeah. I think that's all good. Yep. I think that's it. That's that project done. That took a while, but it was my first time doing something like that, so I'm just glad that I finished it. But anyways, thanks for watching. See you guys tomorrow.